Hello, my dear students. I welcome you all in the lecture series of Module 3rd of Measures of Dispersion, which is the third unit of the course Business Statistics. Myself, Mohammad Ashraf, Assistant Professor in Commerce. In order to study the extent of asymmetry and direction, in a series, various measures of skewness are employed. These measures of skewness can be both absolute and relative. In this lecture, I will explain three important relative measures of skewness. The first relative measure of skewness is called Pearson's coefficient of skewness, which is most frequently used for measuring skewness. The formula for measuring coefficient of skewness using this method is mean minus mode divided by standard deviation, or 3 into mean minus median divided by standard deviation. If Karl Pearson's coefficient of skewness is greater than 0, then we can say that curve is positively skewed. When Karl Pearson's coefficient of skewness is less than 0, then the curve is negatively skewed. When the value of Karl Pearson's coefficient of skewness is equal to 0, then we can say that curve is symmetrical. Let us understand how to calculate Karl Pearson's coefficient of skewness with the help of this example. We have marks 20, 22, 27, 30, 31, 32, 35, 40, 45 and 48. We can calculate coefficient of skewness using any of the formula discussed earlier. That is, either by deducting mode from mean or deducting median from mean. Here I will be calculating coefficient of skewness using mean and median. So at first, we have to calculate mean and median. In this example, total number of observations is 10. Since this is ungrouped data, x bar will be equal to summation x divided by n, that is 330 divided by 10, which comes out to be 33. So our mean is 33. Now we have to calculate median. The formula for calculating median is size of n plus 1 divided by 2th item, which comes out to be 5.5th item, which means median lies somewhere between 5th and 6th item. So median will be calculated as 5th item plus 6th item divided by 2. In this example, 5th item is 31 and 6th item is 32. So median will be equal to 31 plus 32 divided by 2, which comes out to be 31.5. Now we have to calculate standard deviation for ungrouped data. The formula for calculating standard deviation is under root summation x minus x bar raised to power 2 divided by n. By applying the formula, we get standard deviation is equal to 8.76. Now we have calculated all the values. We have mean is equal to 33, median is equal to 31.5, standard deviation is equal to 8.76. Putting these values in the formula for calculating Karl Pearson's coefficient of skewness, that is 3 into mean minus median divided by standard deviation, which comes out to be 5.14. Second relative measure of skewness is Bolle's coefficient of skewness. Bolle's coefficient of skewness is defined in terms of the quartiles. We know that the quartiles are 1, We divide the total frequency distribution in 4 equal parts and we have thus 3 quartiles Q1, Q2 and Q3. So Borlase coefficient of skewness is based on these quartiles. The formula for measuring coefficient of skewness using this method is third quartile plus first quartile minus 2 into second quartile divided by third quartile minus first quartile, where Q3 is upper quartile, Q2 is median and Q1 is the lower quartile. If the Borlase coefficient of skewness is greater than 0, the curve is positively skewed. When Borlase coefficient of skewness is less than 0, then we can say that curve is negatively skewed. And when the value of Borlase coefficient of skewness is equal to 0, then the shape of the curve is symmetrical. In order to understand this method in a better way, let us take an example. We have scores 56, 58, 3 times 60, 62 and 64. As per the formula, we have to calculate Q1, Q2 and Q3. This is ungrouped data. The total number of observations is 7. Q1 is calculated as size of n plus 1 divided by fourth item, which is equal to 8 divided by fourth item, which comes out to be second item. Now the second item in the example is 58, so our Q1 is equal to 58. Q2, which is median, the formula for calculating Q2 is size of n plus 1 divided by tooth item, which is equal to 8 divided by tooth item, which comes out to be fourth item. The fourth item is 60, so Q2 will be equal to 60. Now we have to calculate Q3. Q3 is equal to size of 3 into n plus 1 divided by fourth item, which is equal to 3 into 8 divided by fourth item, which comes out to be sixth item. The sixth item is 62, so Q3 will be equal to 62. Hence, Borlase coefficient of skewness is equal to third quartile plus first quartile minus 2 into second quartile divided by third quartile minus first quartile. Putting these values in this formula, we get Borlase coefficient of skewness is equal to 0. The third method for measuring skewness is Keeley's coefficient of skewness. Keeley's coefficient of skewness is defined in terms of the percentiles and deciles. The formula for calculating Keeley's coefficient of skewness is on the basis of percentiles. Keeley's coefficient of skewness is equal to 90th percentile minus 2 into 50th percentile plus 10th percentile divided by 90th percentile minus 10th percentile. The formula of calculating Keeley's coefficient of skewness based on deciles is 9th decile minus 2 median plus first decile divided by 9th decile minus first decile. In order to understand this method in a better way, let us take this example. Here we have 9th decile is equal to 30, median is equal to 21 and first decile is equal to 7. Since in this question information relating to deciles are given, we will be calculating Keeley's coefficient of skewness using formula based on deciles. The formula based on deciles is ninth decile minus 2 median plus first decile divided by ninth decile minus first decile. By putting these values in this formula, we get minus 0.22. Hence, the distribution is negatively skewed. Thank you.